We're going to begin looking at alternative methods to solving polynomials. We've done it through factoring, we've done it through the graphing calculator, and today we're going to begin looking at the rational root theorem. The rational root theorem means that you're going to take a polynomial. So what I'm highlighting right here is just what a polynomial format looks like when it's in standard form. And we're going to make a comparison out of two pieces called the P over Q. Now, our P piece is going to come from the constant back here at the end. So this is going to be the P. And the Q is going to come from the leading coefficient at the front. So those are the pieces that you'll want to identify, again, once it is in standard form. So the Q that we're going to be looking for is the leading coefficient, and we're going to be looking for the factors of that. We'll also be focusing in on our P, and the P is going to be the constant term and the factors of that constant term. So in the first question, in example 1, we're going to be focusing on the 8. That's going to be the p-value. And don't really worry about the positive or negative in front of the 8, because when we write our ratios, we're going to include both the positive and negative, so we don't really have to get worried about whether that constant is positive or negative. And then the Q that we're going to look for in this first question is 4. That's the first piece of getting yourself started the right way. Identify your P, which for us is 8, and then we want to list the factors of 8. So 1 times 8, 2 times 4. So 1, 2, 4, and 8 are all the things that can multiply together to get 8, or that divide into 8 without a remainder. And then you have Q. I have had identified our Q as 4. That's your leading coefficient. And then again, we want the factors, and I'm getting that out of the definition of the process up above. The factors of 4 would be 1 and 2 and 4. So that's where we begin. We have to know what those values are so that we can begin to create our ratio. Now we're going to find every possible combination of the P factors divided by the Q factors. So I like to do mine kind of systematically. I recognize that I need 3 different denominators. I'm going to have 1 as a denominator, I'm going to have 2 as a denominator, and I'm going to have 4 as a denominator. And again, I'm getting those from the Q value, and these were all of my Q's, 1, 2, and 4. And so now I'll focus in on my numerator, the P's. So for each of those denominators of Q, 1, 2, and 4, now I'm going to put these 4 values of P with them. So to start off with, I mentioned a moment ago, we're going to do both the positive and negative version of this. So I'm going to have 1 over 1. I'm going to have plus or minus 2 over 1. I'm going to have plus or minus 4 over 1. And again, I am just using each one of these P values. And then I also need a plus or minus 8 over 1. Now you may be recognizing that fractions that have a denominator of 1, we don't usually write it with the 1. You certainly don't have to. I'm just doing that as we get started here. Then we'll go to our second possible denominator, which is a 2, and we need to build those exact same numerators. So now I have plus or minus a half. I have plus or minus 2 halves. I have plus or minus 4 halves. I have plus or minus 8 halves. And then we'll move to our third possible denominator. We have plus or minus 1/4, plus or minus 2/4, plus or minus 4/4, and plus or minus 8/4. Now, some of you may be looking at those different possibilities there and realizing that we've got some numbers that are the same if we reduce them, or as we reduce them, we recognize that. For instance, in the second row, 2/2, that's the same thing as the one that we had previously. So we don't want to worry about the duplicates. So I'm just going to cross them out. 4 divided by 2 is 2. We have that. That's a repeat. 8 divided by 2 is 4. That's a repeat from the first row. The 1/4 is new, so we keep that. 2/4, that's the same thing as the 1/2 that we had as the first term in the second row. 4/4, that's a repeat of 1. And 8/4, that's a repeat of 2. So we narrow it down then to this group of values. And you'll have some questions today where it's just asking you to name the possibilities. And these would be the possibilities for our rational roots, or things that would divide into our polynomial without a remainder. So we end up with 2 of each of these. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 1/2, plus or minus 1/4. So you end up with 2, 4, 6, 8, 10, 12 possibilities. For a value that's rational that will divide into our polynomial without a remainder.